Welcome to my channel. My channel is at Anthony Sir MAD. Please subscribe my channel. Today we are going to discuss about Cbse 11th standard physics. Motion in a plane. The chapter is motion in a plane. All Cbse 11th standard physics students, please watch this. State whether the following physical quantities are scalar or vector. They are given mass, volume, speed, acceleration, density, number of moles, velocity, angular frequency, and displacement and angular velocity. So all these scalar quantities are density, mass, speed, volume, angular frequency, number of moles. Vector quantities are velocity, acceleration, angular velocity, and displacement. First of all, scalar quantity depends only on the magnitude and it is independent of the direction, density, mass, speed, volume, angular frequency, and the number of moles are scalar quantities. Vector quantity depends on the magnitude as well as the direction. Scalar quantity depends only on magnitude, but vector quantity depends on the magnitude as well as the direction. So velocity, acceleration, angular velocity, and displacement comes under this. The next question, read each statement below carefully and state with the reasons if it is true or false. First one is the magnitude of vector is always scalar. Second one is each component of vector is always a scalar. Third one is the total path is always equal to the magnitude of the displacement vector of a particle. And fourth one is the average speed of a particle is either greater or equal to the magnitude of the average velocity of the particles over the same interval of time. Finally, three vectors not lying in a plane can never add up to give a null vector. The answers are, first one is true because the magnitude of a vector is a number, so it is a scalar. The second one is each component of the vector is also a vector, so this is false. The third one is also false because the total path length is a scalar quantity, whereas displacement is vector quantity. Hence, the total path length is always greater than the magnitude of the displacement. So it becomes equal to the magnitude of displacement only when a particle is moving in a straight line. Then the fourth one, D, is true because it is because of the factor that the total path of the length is always greater than or equal to the magnitude of displacement of a particle. And the last one is true because three vectors which do not lie on a plane cannot be represented by the sides of the triangle taken in a same order. Next question is read each statement below carefully and state with the reasons and examples if it is true or false. A scalar quantity is one that option A is conserved in a process, then B can never take negative values, C must be dimensionals, D does not vary from one point to another in space. E has the same value for observes with different orientation of axis. The answer is, the first one is false, because despite being a scalar quantity, energy is not conserved in any elastic pollution. Second one is false, because despite being a scalar quantity, the temperature can take negative values. Third one is false. The total path length is a scalar quantity, yet it has a dimension of the length. Fourth one is also a false. A scalar quantity such as gravitational potential can vary from one point to another in space. And finally, the E is true, because the value of a scalar quantity does not vary from observes with a different orientation of axis. Next question is, a bullet fired at an angle 30 degree with the horizontal hits the ground 3 kilometers away. By adjusting its angle of projection, can one hope to hit a target 5 kilometers away? Assume the muzzle speed to be fixed and then neglect air resistance. So your bullet is fired at an angle 30 degree. Okay. The bullet hits the ground at a distance of 3 kilometers, that is 3000 meters. The horizontal range, that is capital R, is equal to U squared sine 2 theta whole divided by G. So they are given R is equal to 3000. That is equal to U squared sine 600 whole divided by 9.8. So U squared is equal to 3000 into 9.8 into root 3 by 2, sine not 600, sine 60. Sine 60. So root 3 by 2. So 2 into 3000 into 9.8 whole divided by root 3. That means 58,800 divided by root 3 value in the 1.732. So divided by this gives 33,949. And also R dash equal to U squared sine 2 theta divided by G. That is equal to 5,000. So our answer must be 33,949 into sine 2 theta whole divided by 9.8. Sine 2 theta is equal to 5,000 into 9.8 whole divided by 33,949. So 49,000 divided by 33949 equal to 1.44. The sine of an angle cannot be more than 1. Therefore, the target 5 kilometers away cannot be hit. Next question is, a fighter plane flying horizontally at an altitude of 1.5 km with a speed of 720 km per hour passes directly overhead an anti-aircraft gun. At what angle from the vertical should gun be fired for cell with missile speed 600 meter per second to hit the plane. At what minimum altitude should be the pilot fly the plane to avoid being hit? So taking G as 10 meters per second square. The answer must be speed of a fighter plane 720 kilometers per hour. That means 720 into 5 by 80 meter per second. That means 200 meter per second. The altitude of the plane is 1.5 km kilometers. Velocity of the cell 600 meter per second. Sin theta 1 by 3 because 200 by 600 1 by 3. So theta is equal to sin inverse 1 by 3. That's equal to 19.470. Let h be the minimum altitude using equation h equal to u squared sin 90 minus theta whole divided by 2g. So 600 squared sin 2 theta sin squared theta divided by 2g. So 600 squared cos 2 theta divided by 2 cross 9.8.